Hi guys. Well, we're starting 5.3. Guys, our first day of 5.3 today. We'll be spending a few days on this. And what's changing is we're leaving the verifying trig identities that we've been working on for a few days now, and we are moving to solving trig equations. Okay, so the important things here are we're solving equations. Okay, we can now use standard algebra techniques. Those are my little air quotes there, which means we can move things algebraically from one side to the other. We can add things, subtract things, to move things from one side, divide both sides by 2, all of those sorts of things that you did in algebra when you solved equations. Okay, our goal is to isolate the trig function. Okay, when we were in algebra, we were isolating the variable or the x, and now we're isolating the sine of x or the cosine of x or the tangent of x. We can do all the normal things that we did in algebra. We can combine like terms, we can factor, we can do all those sorts of things. Okay, the other thing that's new that we haven't seen in a while, I shouldn't say new, this is obviously an old friend here, but the unit circle is coming back. So you're going to need to have a copy of a unit circle that you can reference. I found the one in the book was really small inside the front cover to try to have you guys be able to see this in the notes. So I printed this out off of the internet if you have the option to do that. And I've actually just put it on the back of my little note card so that I can find it easily when I'm working here at home. Okay, so you will need a unit circle of some sort. Okay, all right, so we're going to start out with this first example here. And in this first example, this homework is going to start out just like this. They're just going to give you some values. They're not going to ask you to solve the trig equation. They've actually solved it for you, and they want you to verify that these actually are the solutions. Okay, so what we're going to do is take these numbers and plug them in for x. Okay, so I'm going to take this 5 pi over 4 and put it in here. And I'm going to take 5 pi over 4 and I'm going to put it in here. Okay, so we need to go to our unit circle to find out what the sine of 5 pi over 4 is. Okay, so we find 5 pi over 4. And remember that it's cosine sine. So the sine is our y value. Okay, it's been a long time since we've used that. Okay, so our sine is the negative square root of 2 over 2. In this case, they're equal, but doesn't matter. We want the y value. Okay, so this is the negative square root of 2 over 2 plus the square root of 2 is equal to negative. And then the same thing, the sine of 5 pi over 4 was again the negative square root of 2 over 2. These two negatives are going to become a positive. And if I add the square root of 2 over 2 to both sides, this side is now the square root of 2. This side, the square root of 2 over 2 plus the square root of 2 over 2 is 2 square roots of 2 over 2. And the 2's cancel, and we can see that both sides are equal to the square root of 2. Okay, the good news is, this was part A. When we go to part B, it's going to look exactly the same. And if you just want to write this in your homework, if it happens to work out that way, I'm okay with that. Because when I go to 7 pi over 4, I can see that the sine is still the negative square root of 2 over 2. So everything is going to work out exactly the same if I change this to 7 pi over 4. Okay, so the first few questions, that's all you're going to be doing. Plugging the answers in and seeing if they work. Okay, then you're going to get to some problems like these other 3 examples here, where you're actually going to be using algebra to solve for what x value, what angle will make this true. Okay, so if we were in algebra 1, this right here would have looked like this. Okay, and if I gave you guys a problem like that right now, you could do it in your sleep, obviously. Add 1 to both sides, divide both sides by 2, and x is equal to 1/2. We're going to do the exact same thing, only we're not going to get x is equal to 1/2. We're going to get the sine of x is equal to 1/2. Okay, so I'm going to add 1 to both sides. I'm going to divide both sides by 2. Okay, so the sine of x is equal to 1/2. And this is where we want to go to our unit circle. Okay, so we're going to go to our unit circle and we're going to find out when is the sine equal to 1/2. Okay, remember sine is the y value. Okay, so my first answer as I'm going around my unit circle, oh, by the way, I forgot to point this out, and this is super important. We are only looking for the answers that are in this interval. And remember, this meant included. This means not included. Sorry, that arrow came out terrible. Not included. Okay, so it means what are the answers on the unit circle? And if this ends up being my answer, 0 is what I'm going to write because 0 is included, 2 pi is not. So I don't want to call it 2 pi, I just want to call it 0. Okay? So when is the sine on the unit circle equal to 1/2? Well, here's one answer right away, pi over 6. So that's one of my solutions. 2 times the sine of pi over 6 minus 1 is equal to 0. Okay? Let's go back to our unit circle and see if there are any other points that have a y value of 1/2. There's one right here at 5 pi over 6. Okay, and I can keep looking, but I'm telling you right now, I think all my y values in the lower half of the circle are going to be negative. So I think those are going to be my only 2 answers. Okay, so on the first few problems, you are just verifying to see if their work is correct. Here, you're actually coming up with the solutions. Okay, and as you can see, it's just like Algebra 1, only you're not solving for x, we're solving for the sine of x, or it could be the cosine or the tangent. Okay, and then we go to our unit circle and see when that's true. Okay, hopefully that's making sense because we're going to go to a couple little bit more complicated examples. I started out with a nice easy one. Okay, this one has got some sine squareds in it. So think about it, it's a quadratic equation. And I want you to think about if we were in Algebra 2, not Algebra 1, because we didn't know about quadratics, but we were in Algebra 2 and we had this problem, which you can see is exactly the same, only instead of the sine of x's, I just put x's. Okay, what would we do with this? Oh, did I hear somebody say factoring? Absolutely correct. Okay, and I need to factor this. And some of you may have to do AC method to factor that. Hopefully not. I am not a fan of the AC method because it really slows you down when you get to this point. Okay, I know this is a 1. I know this is a 1. I just have to figure out which one's positive, which one's negative. And I think it goes this way because this becomes negative 2x. And this becomes positive 1x, which adds up to this negative x that's in the middle. Okay, so this is what this is going to look like in factored form, but the only difference is instead of having x, we're going to have the sine of x. Okay, so 2 sine of x plus 1 times the sine of x minus 1 is equal to 0. Okay, and if we go back to our Algebra 2 example, what would we do next? We would set this equal to 0, and we would set this equal to 0. That's exactly what we're going to do here. So this is going to be equal to 0, and this is going to be equal to 0. Okay, so 2 sine of x plus 1 equals 0. I'm going to subtract 1 from both sides. I'm going to divide by 2. So I'm looking for where my sine of x is equal to negative 1/2. Okay, I'm going to go to my unit circle and see when that's true. My y value, negative 1/2. There's 1, 7 pi over 6. Okay, I'm going to keep looking. And there's another one, 11 pi over 6. Okay, so I've got 2 answers so far, but I've only set one of my terms equal to 0. I need to do the same with the other term. I'm going to add 1 to both sides. Oh, I need my sine of x to be equal to 1. So again, I'm going to go back to my unit circle. Once I isolate my trig function, go back here, and oh, the y value has to be 1. There we are then, pi over 2. Okay, so 3 solutions this time. 2 of them came from this equation. 1 of them came from this equation. Okay, not too bad, is it? Okay, some of you are like, yes, I'm just so glad we're done with 5.1 and 5.2. I don't care what you make me do. All right, this last example, take a deep breath here, because it's a little messy, okay? Normally, when you're doing these kind of problems, you don't have to use trig identities. But this one, we do need to use one trig identity at the very beginning, okay? And I want you to look at our last example and tell me what the difference is between these two, okay? Well, on this one, we had all signs of x, okay? So it was like they were both all x's. But in this one, we've got a sine squared, and then we've got a cosine, okay? So I have a problem there. I can't have mixed trig functions if I'm going to try to factor this like I did on the last problem. So I'm going to switch my unit circle over here, and I'm going to go back and look at my trig identity. I'm going to put my little thought bubble on one of these little yellow pieces of paper here. If I want to get the sine squared by itself, so that I can replace this, that's my goal, is to get this out of here and call it something else. I start with this Pythagorean. I subtract the cosine squared from both sides. And again, if you can do this in your head, you're doing fantastic. Okay? And the sine squared is equal to 1 minus the cosine squared. So I'm going to replace this right here with 1 minus the cosine squared. Okay, the rest of this is going to stay the same. Okay, and that's the only trig I'm going to use, or trig identity I'm going to use, is at the very beginning, just so that I can get this to all have one trig function. Okay, now I'm going to act like this is algebra, and I'm going to simplify this side. I'm going to distribute this 2. I'm going to combine like terms. Two minus 3 is -1. And now I've got this in standard form with decreasing exponents and all that sort of stuff. Okay? I never like to factor personally with a negative in front of the first term. So I'm going to multiply this whole equation by -1 or divide it all by -1, whichever you want to do, so that I can change these signs. And now my first term is positive, because that always makes it easier to factor. Okay? I'm going to go back over here, back to my little algebra 2 trick. And if you need to write this out, that's perfectly fine. If you can get by without writing it out, that's fantastic. Okay? This has got to be 2x and x. And this needs to be 1 and 1. And this says they're the same. And since it has to add up to a negative, I think they're both negative. Okay, let's check this out. -1x minus 2x, which adds up to the -3x. So I think this is my winner. Okay, except again, instead of x, it's going to have the cosine of x. Okay, and again, just like right here, I could set these equal to 0. I'm going to do the same thing with this. I'm going to set this equal to 0, and I'm going to set this equal to 0. I'm going to add 1 to both sides. Divide both sides by 2. So the cosine of x is 1/2. Okay, and then over here, I'm going to add 1 to both sides. The cosine of x is equal to 1. Okay, so I'm going to go back to my unit circle, and I'm going to see when those are true. Well, when is the cosine, which is my x value, equal to 1/2? There's an answer, pi over 3. Okay, let's keep looking. Not in this quadrant. X's are all negative. Not in this quadrant. But down here at 5 pi over 3, I see another place. And when is the cosine equal to 1? Well, that's going to be right here And again, what do we say we want to call that value? Do we want to call it 0 or do we want to call it 2 pi? Look at our interval, and that interval is never going to change. Standard interval for the unit circle. So 0 is always going to be included, 2 pi is not, so we're going to call it 0. And again, I got 3 answers. Okay? Hopefully that all made sense. Give it a shot on the homework, and if not, I'll see you during Zooms. Okay? I will hopefully see you guys soon. Bye.